Dear students, today we will discuss sulfonation and Friedel-Crafts alkylation and Friedel-Crafts acylation reactions. All are electrophilic substitution reactions. We already discussed about the nitration and halogenation in previous classes. So sulfonation also have the same steps of electrophilic substitution as halogenation and nitration. In sulfonation, firstly electrophile generate and then a covalent bond is formed between the benzene and the electrophile, and finally take a proton away from the benzene. These are the three common steps. But in sulfonation, the electrophile is sulfonium ion. I already told you the difference of electrophile in different electrophilic substitution reactions. So in sulfonation, the electrophile is sulfonium ion. The sulfonation of benzene is carried out using hot concentrated sulfuric acid. Actually, the electrophile generated in sulfonation is sulfonium ion, and it is generated by the reaction of 2 molecules of sulfuric acid. So in step 1, 2 molecules of sulfuric acids react with each other, and one sulfuric acid give their hydrogen ion or proton to another sulfuric acid molecule and to form the H3SO4 and HSO4. This H3SO4 molecule in step 2 again remove the water molecule, remove the H2O and to form the sulfonium ion or HSO3. HSO3. This is the sulfonium ion, or this is the electrophile for the sulfonation reactions. The other steps for the sulfonation same as nitration. In third step, this electrophile or this sulfonium ion form a covalent bond with benzene, and after that in fourth step it take a proton away from the benzene. You can see in nitration benzene and nitronium ion form a covalent bond, and it gives a 3 resonance stabilizing as structures. After that, in last step it take a proton away in fourth step, and it goes to the water molecule, and it is from the H3O and nitrobenzene, and same like this in sulfonation it form the sulfobenzene. This is the sulfonation. So please all of you complete this sulfonation steps in your notebook and remember the things and learn the things how it is going to be sulfonation. Now come to the Friedel-Crafts alkylation. Friedel-Crafts alkylation, as its name represent, alkylation means a alkyl group attached to the benzene by replacing the hydrogen ion. This in Friedel-Crafts alkylation, you can see a new carbon-carbon bond is formed between the benzene and the alkyl group. This Friedel-Crafts alkylation, it is very feasible and mostly used for the formation of new carbon-carbon bond. You can see one carbon from the benzene and another from the alkyl group. You can see the reaction benzene react with 2-chloropropane, and you can see it form the isopropyl benzene, a bond formed between the carbon in presence of aluminum chloride. So in Friedel-Crafts alkylation, same steps repeat like before. first step, formation of electrophile, and this electrophile is formed by the reaction of haloalkane which contain the halogen and alkane group, and this is a Lewis base, and it react with aluminium chloride AlCl3. It is a Lewis acid, and to give a molecular complex with a positive charge on chloride and a negative charge on aluminium. This molecular complex again give the ion pair containing a carbocation. You can see here is a R positive. It is a electrophile for the reaction of Friedel-Crafts alkylation. In step 2, this electrophile forms a covalent bond with nucleophile, or you can say with benzene. By the breaking of bonds in the benzene, it will form the positive and negative charge. On negative charge, this alkyl group attach with covalently with this benzene, and it form a resonance stabilized structure. And after that, in step 3, take a proton away, proton transfer from benzene to any base or AlCl4, and then it give the electrophilic substitution reaction or Friedel-Crafts alkylation reaction. Alkyl group attached to the benzene and to form the new carbon-carbon bond, and AlCl3 and HCl. Alkylation have some limitations, and it is in your syllabus, so please remember the limitations of the Friedel-Crafts alkylation. It have two major limitations. First is Friedel-Crafts alkylation are always possible with stable carbocation. So what is the stable carbocation? Which have the if you can see in between the primary, secondary and tertiary carbocation, then there you can see tertiary carbocation is more stable than secondary, and secondary is more stable than primary. So here this reaction is possible only with stable carbocation. The first is that it is practical only with stable carbocations such as tertiary carbocation, resonance stabilized carbocations, or tertiary carbocations that cannot undergo rearrangements. Less stable carbocation to stable carbocation. It is an example you can see in this reaction. Here 1 chlorobutane react with AlCl3 and benzene to give the 1-phenyl butane. It is a primary carbocation, and it also form the 2-phenyl butane. It is a secondary carbocation, and you can see the percentage of formation of secondary carbocation is 65%, and only 35% is formed primary carbocation. Means this reaction is feasible only with secondary carbocation. The second limitation is if any benzene have the electron withdrawing group, then Friedel-Crafts alkylation reaction is not possible, because electron withdrawing group take the electrons from the ring and deactivate the ring. So if any phenyl ring or benzene ring have the electron withdrawing group, then this Friedel-Crafts alkylation reaction is not possible. You can see here I given so many reactions, so many examples of the electron withdrawing groups like CHO, SO3H, CF3. So many examples. Please remember all these examples which are electron withdrawing and deactivate the ring, and in this condition no any Friedel-Crafts alkylation reaction is not possible. In next class we will discuss Friedel-Crafts acylation and their limitations. So remember all the things. Thank you.